Hello guys, let's continue our section on orifice and mouthpiece. On the previous sections we are dealing with orifices and mouthpieces, and we gone through the flow through an orifice, finally came to know about vena contracta and theoretical velocity. Finally, we gone through the hydraulic coefficients such as coefficient of velocity CV, coefficient of contraction CC, coefficient of discharge CD. Coefficient of velocity is nothing but the ratio between the actual velocity of the jet at vena contracta and the theoretical velocity of the jet. Okay, theoretical velocity is taken as root 2 gh, where h is the head. Okay, coefficient of contraction is a ratio of area of the jet at vena contracta to the area of orifice. Okay, then coefficient of discharge, it is nothing but the ratio of actual discharge from an orifice to the theoretical discharge from the orifice. Okay, guys, also keep in mind that there is no need of mentioning the term vena contracta in the definition of coefficient of discharge. The previous hydraulic coefficients we use the term vena contracta. Okay, coefficient of discharge is nothing but the ratio between the actual discharge from the orifice to the theoretical discharge. Okay, then final relationship between all the three hydraulic coefficients. CD is equal to CV into CC. Okay, let's move on to the first problem. The head of water over an orifice of diameter 40 mm is 10 meters. Find the actual discharge and the actual velocity of the jet at vena contracta. Take CD, coefficient of discharge, as 0.6 and CV, coefficient of velocity, as 0.98. Okay, in the question we have the orifice diameter as 40 mm. Also it is given that the head of water, it is nothing but height or head, it is given as 10 meters. What we have to find is the actual discharge and the actual velocity of the jet. Okay, and we have value of CD and CV. First of all, let's mention the given values from the question. The head is given as 10 meters. So h is equal to 10 meters. It's not in centimeter, it is in meters. Okay. Then diameter of the orifice, small d, which is equal to 40 mm. Converting it into meters gives 0.04 meter. Then area of the orifice, which can be given by the equation A is equal to pi by 4 into d square, where d is the diameter of orifice, 0.04. Okay, then moving on, we have the equation for coefficient of discharge, which is actual discharge by theoretical discharge, is given as 0.6. Okay, CD is equal to actual discharge by theoretical discharge. Guys, the problem is we don't know either the value of actual discharge or theoretical discharge. Both values are unknown to us. Okay, all we have is the discharge, coefficient of discharge, which is equal to 0.6. So For finding the actual discharge through the orifice, first of all, we have to find out the theoretical discharge. For finding the theoretical discharge, we have theoretical discharge is equal to theoretical velocity into area of orifice. We all know the equation. Q is equal to A into V, where Q is the discharge, A is the area, and V is the velocity. The same equation is used here for finding theoretical discharge, which is nothing but area of the orifice. Area of the orifice into theoretical velocity. Theoretical velocity. Okay. For finding the theoretical velocity, we have the equation root 2gh. Okay. And substituting the value of h height over here, we get theoretical velocity as 14 meter per second. And finally, substituting this value in this equation, we get the theoretical discharge as 0.01758 meter cube per second. It is not meter square per second, meter cube per second. Okay, then finally to the root equation, actual discharge by theoretical discharge. We already find out theoretical discharge of the orifice. Back substituting the value of theoretical discharge in this equation, we get the actual discharge of the orifice, which is nothing but 0.6 into theoretical discharge. Okay, we get actual discharge as 0.01054 meter cube per second. Okay. Also keep in mind that the value of actual discharge is always less than that of theoretical discharge. Moving on. Then second part of the question, actual velocity. Then we have CV, coefficient of velocity, which is equal to actual velocity by theoretical velocity. This is given as 0.98. We already find out the value of theoretical velocity. Okay. Substituting the value of theoretical velocity 14 meter per second over here, we get the actual velocity, which is equal to 0.98 into 14, which is equal to 13.72 meter per second. Okay. Moving on to the second problem. The head of water of the center of an orifice of diameter 20 mm is 1 meter. The actual discharge through the orifice is 0.85 liter per second. Find the coefficient of discharge. In the question, it is given that the diameter of the orifice is 20 mm and the head of orifice, which is given as 1 meter. The actual discharge through the orifice is 0.85 liter per second. Find the coefficient of discharge. Okay, first of all, let's mention the given values in the question. See, diameter of the orifice, d is equal to 20 mm, converting it into meters. Area, A is equal to pi by 4 d square. Okay, we got the area of orifice. Finally, head, h is equal to 1 meters. And moving on, the actual discharge in the orifice is given as 0.85 liter per second. It can be converted into meter cube per second by dividing this term by 1000. Okay. Theoretical velocity Vt is equal to root 2 gh, which is nothing but 4.429 meter per second. Also, we have theoretical discharge Q theoretical, which is equal to V theoretical into area of orifice. Okay. Finally, the coefficient of discharge, actual discharge by theoretical discharge. Actual discharge is given in the question as 0.85 liter per second. We convert its value into meter cube per second. Then also we find out the value of theoretical discharge. Finally, substituting those values over here, we get the coefficient of discharge of the orifice as 0.61. Guys, also keep in mind that there is no unit for any of these hydraulic coefficients. In the case of coefficient of discharge, coefficient of contraction, or coefficient of velocity, we don't have any units. Okay, they are unitless quantities. Clear? Then let's wind up this section and thank you.